So we continue with the fuse part. We are now to the working of the fuse. So working when current is in the circuit exceeds the specified value due to any reason such as the high voltage, short circuiting, overloading, etc. The temperature of the fuse wire rises to an extent that it melts. As a result, a gap is produced and the circuit breaks. Now current does not flow through the live wire and the appliance is saved, or the circuit is saved. After removing the fault in the circuit, a new fuse wire of the same current rating is connected in the holder to complete the circuit again. So as I told you that if this socket and this is the fuse which is connected, fuse wire is placed over here. So in case there is some fault in the circuit over here, then this fuse is going to blow off. So automatically the circuit is going to get open and the current will not flow to the circuit. Now you are going to repair the circuit and see that whatever was the problem has been sorted out. Again put a new fuse here, put it back over here and see whether everything is perfectly normal or not. If it is not still normal, then this will blow off again. So safeguarding your appliances again and again. Nowadays, the costly appliances such as refrigerator, air conditioner, geyser, television, etc. are provided with a cartilage fuse type fuse of proper current ratings such as 1 ampere, 2 ampere, 5 ampere, 10 ampere and 13 amperes. So if you see, there is a glass tube. In glass tube के बाजू में दो metal के pieces होते हैं. So it is made like this. So there will be a metal cap, a glass tube here inside, and then there will be a metal cap again. This thing is a fuse which will be having a thin wire inside. And also there will be written over here कि उसके ऊपर लिखा रहेगा ये 10 ampere या 5 ampere ऐसा लिखा रहेगा इसके ऊपर. This is a cartilage fuse which is going to be there and placed inside that particular socket of the inside the refrigerator or inside the microwave oven. उसमें रहता ही है. So this is kind of a cartilage fuse so that you are not putting anything other than this particular rated fuse inside the things and destroying the circuit of the appliance. Now you can see that when we had drawn this thing, I had connected the fuse to the line wire. It was on a line wire that I connected this fuse. I did not connect it to the neutral. Why did I do this? Why is it necessary for me to connect the fuse into the line wire? Now one of the reasons is that suppose this would have been the neutral and this is the line, then what would happen? Even if the fuse has blown off, the current will still continue to flow into the device and come over here. Now because this is blown off, so this is not going to work, but in case somebody comes over here to repair it and he touches this thing, he will be the return path to connect it to the ground. So suppose I touch this particular bulb. Okay, I thought that okay, fuse तो उड़ी गया तो यहाँ पे कोई current तो pass हो नहीं रहा है. तो if I touch this thing, the current will pass through this wire, come to the bulb and pass through me and enter into the earth. So the earth, we know that the neutral and the earth both have the same potential. So instead of current passing to the neutral and coming here, it is passing to the earth. So the device will get the same current which it was getting earlier, which was a higher value. So no doubt I will get a shock, but also it will damage the appliance. Of course मेरा shock लेना ज़्यादा important है, right? Damage होगा तो ठीक है, मुझे कुछ नहीं होना चाहिए, of course. But anyways, the point is that suppose the shock is very mild, so it is not a problem to me. But yeah, definitely the current will be still going through if the fuse is not connected to the live wire. So the live wire breaks up the supply immediately and does not allow the flow of current, but the neutral wire is just a return path. So live wire पहले दे तो रहा है, ऐसे neutral paths के क्या होगा? The current is not getting completed, so the circuit is not completed. But अगर उसको कहीं पे भी कोई भी point मिल गया, like earthing or something which can be a return path, then it will get the current required for it. So the reason for connecting the fuse in the live wire, the fuse is always connected in the live wire before the appliances so that as the current in the circuit exceeds the rating of the fuse, it may melt and break the circuit first before the current reaches the appliance. Thus no current flows in the appliance here. The first thing is that, yes, if it breaks here itself, so if this is the line wire, what will happen? This will itself break off. So इसलिए जाने का chance ही नहीं है. Right? There is no way the current can flow further. If the current आगे जाएगा नहीं तो appliance तो बच ही गया, बराबर से बच गया without any problem. So first thing is that. So in the figure 9.16, the fuse F is connected in the live wire joined to the appliances through the mains. The circuit is complete and the current flow in the appliance. In figure 9.16b, due to the voltage fluctuation or short circuiting, if excessive current flow, the fuse F blows off, the circuit becomes incomplete and no current flows in the appliance. It is unsafe for the current to connect the fuse in the neutral wire. Figure 9.17 shows the fuse in the neutral wire. If due to some defect in the appliance, an excessive current flows in the circuit, the fuse blows off and current stops flowing in the circuit. But the appliance will still remain connected to the high potential of the supply through the live wire. Now, if a person touches the faulty appliance, he gets an electric shock because the person comes in direct contact with the mains through the live wire. Thus, he is highly unsafe. It is highly unsafe to use fuse in the neutral wire. So that's what I explained you. So first of all, of course, live wire तो उसको disconnect करेगा ही करेगा. दूसरा है कि अगर न्यूट्रल वायर में कनेक्ट किया तो लाइव वायर से कनेक्ट होने के बाद में इफ आई टच दिस पर्टिकुलर थिंग the person will get a shock. So that is what they explained you in the circuit diagrams of 9.16 and 9.17 A and B. The next what we see is the current rating of the fuse. In electric wiring or for lighting and fan circuits, a thin fuse wire of low current rating, that is 5 amperes, is used because the line wire has a current carrying capacity of 5 amperes. A thick fuse wire of higher rating, 15 amperes, is used for heavy current consuming appliances such as air conditioner, geyser, washing machines, etc. Because the line wire has such appliances has a current carrying capacity of 15 amperes. The current rating of the main fuse in a ring circuit is 30 amperes, while for a company fuse is 50 amperes. The current rating of fuse in a circuit can be obtained by the following relationship. Current rating of the fuse is total power of the appliance of the circuit upon voltage of the supply. So current capacity rating is nothing but the safe current or current which is P upon V. So current rating के हिसाब से you find out the fuse rating. Okay, the current rating, the current which is being taken in by the supply by the appliance will also give you the fuse rating. Normally, we will be using fuse rating of 5 amperes for most of the small appliances, and for bigger appliances we'll be using 15 amperes. AC, geysers and all will require 15 amperes, whereas the small ones like tube light, fans and all will require 5 amperes. So that is how we are going to have it. Of course, we know that the company fuse will be 50 amperes. The fuse at the household, the main fuse of your house will be 30 amperes. So current rating of certain appliances are given over here. That you can see electric bulb, it takes only 0.27 amperes. Television takes only 0.54 amperes. Refrigerator is 0.68 amperes. Electric mixer 3.4 amperes. Electric heater is 4.5 amperes. And is 4.5. You can see all these are below 5 amperes. That's why the fuse rating for all of them will be only 5 amperes. Whereas geyser is 7 amperes, so we take a 8 ampere fuse. Electric kettle is 8.3, so we take a 10 ampere fuse. Electric oven is 13.6, so we take a 15 ampere fuse. So these are the fuse ratings of certain appliances where they also given the power rating. So if at all, suppose ये one ball छोड़ दो, अगर कोई भी appliance अगर 3 kW का है, okay, that is 3000 watt का अगर है, then it will require 15 ampere fuse rating. Okay, that is the last thing as problem. Note, the fuse provided or connected with an electric appliance to protect it against electric faults must be of current rating a little more than the maximum current that can be drawn by the appliance before being overheated. But some electric appliances such as mixers, water pump, etc. having an electric motor in it draws a heavier current when it is switched on as compared to that when it is running condition. So the fuse for such appliances must be of current rating somewhat more than the starting current. For example, a water pump rated 1.5 kW has a motor which draws current 10.4 amperes at the starting, while running it is 6.8 amperes. Hence, the fuse must be of a rating not less than 10.5 amperes. So what they mean to say over here is that many appliances, because they have a motor inside, so initially to overcome the inertia and overcome the resistive forces in the start, okay, so due to that they need some higher amount of torque or higher amount of force for its start of the rotation. So that particular higher torque is available to the motor by a higher current at the start. So when a higher current is made to pass through at the start, it immediately gives you the rotation of the mixer grinder and all. So that's why they are going to be taking higher current during the start, and then when they are running at that time the current drops down. So all these, so example they are given over here is of an electric water pump. So water pump takes a current of 10.4 amperes at the start of the pump, and it is going to gradually become 6.8, or not gradually, it is going to become 6.8 amperes when it starts running. So that's why the fuse rating, if it is less than 10.4, then automatically start होते ही वो fuse उड़ा देगा. So fuse कैसा होना चाहिए? 10.4 से थोड़ा ज़्यादा, so that initially also when the spike of the current is taking place at the start, at that time it is not getting blown off. So that's why you will see that certain instruments or certain devices will require higher rating of the electric current, even if the normal running के time पे the electric current supplied to them is low. Next is MCB. Nowadays, instead of fuse, a miniature circuit breaker MCB is used for each individual circuit. If due to short circuiting or some fault, a heavy current flows in the line, the MCB falls down to switch off the circuit in a very short time, that is 25 milliseconds. After repairing the fault in the circuit, the MCB is then raised up. Thus, the use of the MCB is more convenient than the fuse because it avoids the inconvenience of connecting a new fuse wire, and it is much safer due to its quick response. See, fuse यार में क्या था? किसी ने मिस्टेक से जाड़ा वायर डाल दिया, या तो किसी ने प्रॉपर वायर यूज नहीं किया. यहाँ पे MCB is very safe. First of all, it will trip very fast. That is 25 milliseconds. In just 25 milliseconds, if that current goes for more than certain limit in 25 for more than 25 milliseconds, it will just trip. When it trips, automatically you're just going to check whether the circuit is proper or not, if there's any problem with the device and all. If you find that everything is okay and you switch it on, it will be back again. So you just have to reset the MCB. Reset the MCB is just वो अपने आप trip हो जाता है, गिर जाता है, उसको सिर्फ हम लोग ऊपर करना होता है. That's the simple thing. So it is just like operating a switch. Okay, the MCB is just like a normal switch. So but it has got a device that switch normally हम लोग अपने आप off नहीं होता है. यहाँ पे ऐसा switch जो अपने आप को off कर देगा if the more amount of current is passing through. That's why it's called as a miniature circuit breaker. Okay, circuit breaker. It is breaking the circuit. That is called as a miniature circuit breaker, which operates at a very fine timing, and response time is very high, very low. And another thing is that it removes the hassle of changing the wire. Plus, many times a person may not know how to change the wire. We'll have to call an electrician for that thing. तो electrician आएगा, fuse डालेगा, फिर करेगा, उसके बाद चालू होगा. So you are waiting just for one simple person to come over there and change the wire for some few hours. So this becomes much more easier of use of MCB. So this was our first appliance, that is the first device we are using in the circuit is MCB. The next device what you are using is called a switch. So that is a switch. This is the switch over here. A switch is an on-off device that for current in the circuit or in an appliance. It is connected in the live wire. So switch, of course, it is a simple on-off device which is either connected to the circuit or it is already present in the appliance. Like for example, you always have a proper switch of on-off on the TV also, plus you will have a outside also. You will be having a plug point जहाँ के साथ में switch है, plus you'll be having one on-off switch of the TV itself, right? Similarly, a grinder also will have its on-off switch, okay? So all of them switches can be external also or could be internal of the device. Switches are of various kinds and they are made in many fascinating designs. We classify the switch into two groups, single pole switch and a double pole switch. So yeah, switches तो बहुत सारे अलग अलग टाइप के होते हैं, टच स्विच एंड फेदर टच एंड यू टॉन्गल टाइप का या किसी में प्लग टाइप का एंड अलग अलग टाइप के फैंसी कुछ ना कुछ निकालते रहते हैं. सो देयर आर डिफरेंट काइंड्स ऑफ स्विचेस बट द मेजर category of switch can be of two kinds. One is a single pole, other is a double pole. Single pole यानी इस साइड का connected only to the live wire, and if it is like this that it is connected to the live as well as neutral at the same time, then it is a double pole. So double pole or single pole. The main switch, the switch used with the appliance to start or stop the flow of the current is a single pole switch. A single pole switch disconnects only the live wire from the appliance. Yeah, so it is connected only to the live wire and is disconnecting the live wire from the appliance. That is the switch, work of the switch. Whereas double pole switch is used in the main board. हम लोग ने पढ़ा था last video में that main circuit से जब भी आता है तो you are using the after the meter, electric meter, kWh meter, you are having a dipole switch, double pole switch, which will disconnect both the live and the neutral at the same time. The main switch at the distribution board used to switch on or off the mains is a double pole switch. A double pole switch disconnects both the live as well as the neutral wire simultaneously. The dual control switch used as staircase etc. is also the double pole switch of special kind. So we are just going to learn one more type of a wiring in which it is called as the staircase wiring. तो वो कैसे काम करता है क्या है, we'll just see that thing a bit later. But there also there is the use of such kind of a double pole switch, but it is of a different kind. It is not the same, but it has got double pole, but not like this one. It is not connected to line and neutral both. It is connected only to the line, but it's of a different kind. It is like a two-way switch which you will normally have in your bedrooms. कि एक स्विच होगा दरवाजे के पास और एक स्विच होगा बेड के पास. तो रात को सोते वक्त हम लोग पहले जैसे रूम में एंटर होंगे तो वी स्विचिंग ऑन द रूम लाइट्स फ्रॉम द डोर साइड एंड व्हेन यू आर गोइंग टू स्लीप एट दैट टाइम यू डोंट नीड टू गेट अप एंड स्विच ऑफ फ्रॉम द बेड्स. यू जस्ट हैव टू द स्विच इज देयर नेक्स्ट टू योर बेड. So why say you are operating it? So that is a double pole. That is a dual control switch. Okay, also called as staircase wiring. Because staircase में भी वैसे होता है. You at the ground floor, you switch it on, you climb up. And then when you reach there, you cannot switch it off, go down and switch it off and then go up. Of course, वैसे तो madness हो जाएगा. So, what you do is that you have a connection such a way that one switch will switch it on and the other switch at the top will switch it off. When you are going downwards, तो वहाँ से switch on किया, यहाँ पे नीचे आके switch off किया. वैसे करके it can be operated in any direction for on and off. So that is called as a staircase wiring. Okay, now we see the reason for connecting the switch to the live wire. So again we have the same reason for same thing. The same fuse is connected to the line wire. The switch is also connected to the line wire for the same reason that अगर switch off कर दिया तो you do not want that the live wire should be giving the supply to the appliances. You are breaking the supply to the appliances when you switch it off. The switch should always be connected in the live wire. 9.1 it shows the switch S connected to the line wire and the switch S is in the on position. The appliance at the bulb gets connected to the high potential point through the live wire and current flows in the appliances because the circuit is complete as the neutral wire provides the return path for the current. In figure 9.18b, in the off position of switch S, the circuit is incomplete and no current reaches the appliances to the live wire. The appliance does not operate, the bulb does not glow. It is now safe to carry out repairs in the appliance if required. Even the live wire connection of the appliance can be touched if the switch is off position because both the line wire and the neutral wire connected with the appliance is at zero potential. So if I switch this thing, suppose I take this thing as, okay, I'll take a circuit over here. So the circuit is like this, that this is a bulb and this is a switch over here. This is the line wire and this is the neutral wire. So if this is off, the current will not flow from here. So if I want to operate any kind of repairs to be taken place over here, I can easily do it without any tension because there is no current coming to here. यहाँ न्यूट्रल से तो आ ही नहीं सकता है, लाइन से हम लोग ने ब्रेक कर दिया है. And if I switch it on, this is going to current will flow like this, it will go like this, and neutral से the bulb is going to glow. So connecting the switch in the live wire ensures that the appliance does not get a supply even if the switch is off. Now the same point, if I have the switch connected here, then what happens? लाइट से करंट जा रहा है, यहाँ पे जा रहा है, यहाँ पे जा रहा है. स्विच ऑफ होने के कारण the bulb is not glowing, but the current is passing through the circuit over here, but because the return path is not available, it is not glowing, it is not functioning. But if I touch this over here, I get a shock and appliances पे current pass होगा. So that is why if I am thinking that okay, switch तो off है, इसलिए मैं इसके ऊपर कुछ काम करूँ, so I go over there and start doing some work over here, and the moment I touch it, I get a shock. So that's why it is not at all going to be advisable to place the switch in the neutral wire, but you should always place it in the live wire. It is deceptive and dangerous to connect the switch to the neutral wire. In figure 9.16, switch is connected in the neutral wire. If in the on position, that is 9.19a, it allows current to flow in the bulb, and in the off position, no current passes through the bulb, thus the switch serves its purpose. But if in the off position of the switch, the appliance remains connected to the high potential terminal from the live wire, although no current flows through the appliance because the return path is incomplete, in this condition, it is not safe to carry out any repairs in the appliance because on touching the live wire in the appliance, the current will pass through the body of the person and he may get a fatal shock. Further, due to some fault or any other reason, if the live wire touches the metal body of the appliance, then it will not safe to touch the appliance even from outside. Thus, if the switch is connected in the neutral wire, it can be quite deceptive and dangerous for the user. So that's why switch should not be connected in the neutral wire because otherwise it will be deceptive. तुम लोग को लगेगा अरे switch तो off है, आराम से काम करने का कर सकते हैं. But in fact, it will turn out to be dangerous and fatal because the current will still pass through the circuit, and if it gets a closed circuit by you being connected to the earth, you are going to get a shock. Safety precautions while using a switch. A switch should never be touched with wet hands. If water reaches the live wire, it forms a conductive layer between the hand and the live wire of the switch, due to which a current passes through the hands through it and person may get a fatal shock. So switch को हम लोग कभी भी wet hand से नहीं operate करना चाहिए, because if when I operating it, if the water enters inside and touches the live wire, because I am touching the live wire, so I am touching it over here, तो ये water को उसको touch करेगा, तो water will be a good conductor to pass it and connect it to me, and hence I'll get a shock. So that's why the switches should not be operated with wet hands. Now the circuit with dual control switch is used over here. So that is the next part, that is circuit with dual control, that is staircase wiring. So we have read that the switch used in the live wire with the appliance to be put off, on and off in a single pole switch. Dual control switch is a double pole switch to special kind which is generally used one at the top and other at the bottom of the staircase, or one each of the opposite ends of the road, long corridor, etc. With such switches, the appliances such as a bulb can be switched on or off from two different places. The connection of a dual control are illustrated in figure 9.20. It is operated in two ways. By switching the knob of A to the right or up, the line wire L connected to the terminal B makes contact with the terminal A so as to make the connection BA through the spring metal strip, And second, by switching the knob to the left, that is terminal B, makes contact with terminal C, so that it makes the connection BC. So that's why it is like this. There will be three terminals, one terminal here, one terminal, one terminal here. So either the connection is between these two, that is the B is connected to A, or you are going to not have this but connected here, B connected to C. So alternatively, so the line is going to be connected here. If the bulb will be connected here, then automatically with the neutral here, then when it is here, it is going to switch on. And if it is connected here, then if this is connected, then this is going to be on. So anyways, exactly what is the dual control switch or staircase wiring, I will just explain you. But this is the connection of the switch. So switch is going to be a double pole switch where the poles will be two. So the connection of the double poles of this is very, very simple. What we have is a bulb, okay, and this bulb will of course be connected to the neutral, and over here you are connecting this to the B of one of the switch. There are two switches. This is switch 1, this is switch 2, this is B over here, and this B is connected to the line wire. So this is your A, C, this is A, this is C, and you are connecting this together and this together. This is the initial condition. So the switch, when it is, one condition is, okay, I'll just take it this way. Suppose it is this way, कि ये ऐसा है और ये ऐसा है. So line wire से current आया, goes to B, goes to C, comes to here, but there is no connection here, so this is off. So this condition over here, where this is connected to AB, and this is connected to BA and this is connected to BC, then the light is off. Now you reach this point and you switch it on, so you take it as A. So here it is now BA, and here also it's BA, and the condition will be on, because this will pass here, pass here, pass here, pass here, pass here, and return to the neutral. Hence the bulb will be on. Now suppose वो आदमी फिर यहाँ पे गया और उसने switch BC कर दिया, तो इसको BC कर दिया. So now it is like this. So what happened? The current comes here, comes here, comes here, comes to this point, but there is no connection here. So this becomes, this is still going to be BA and this is off. Right? Now suppose some another person comes over here and he switches on like this. So now what happened? This is BC and this is also BC, and this will be on. Because it goes like this, goes like this, like this, like this, like this, like this, and this will be on again. Right? We can have multiple combinations. अभी कोई यहाँ से अगर आएगा और उसको AB कर देगा, तो ये AB आएगा और ये BC है, तो this will be AB and BC, so it will be off again. So these are the four options actually. Here AB and here BC off, here AB and here AB on, here BC and here ABA off, BC BC on. So if this and this are different, it will be off. If both are same, it will be on. Okay? So this is called as the staircase wiring or a dual control circuit. So that is what is mentioned over here. In figure 9.21 illustrates the working of a dual control switch. Two switches S1 and S2 are used. The switch S1 is fitted at the bottom and the switch S2 at the top of the staircase. Figure A shows the off position of the bulb. The bulb can now be switched on independently by either the switch S1 or the switch S2. If the switch S1 is operated, the switch connection BA is changed to BC, which completes the circuit and the bulb lights up. Similarly, operating the switch S2 from the position shown in the figure, the connection BC changes to BA, which again completes the circuit and the bulb lights up. Similarly, if the bulb is on the on position as shown and on one switch off, the bulb by changing connection BC to BA, either by operating the switch S1 or the switch S2, but if the bulb is on position as shown in figure, it will be switched to off position by changing the connection BA to BC, either by switch S1 or switch S2. So that's what is the circuit like. In a staircase, while going up, a person puts on the light by operating the switch S1 so that the connection BA changes to BC and makes current flow in the circuit. On reaching at the top, he operates the switch S2 to put off the light so that the connection BC changes to BA and the flow of the current stops. The same system is operative when a person puts on light by operating the switch S2 to change the connection BC to BA and the switch off the light by operating the switch S1 to change the connection BA to BC. So that's exactly the thing. Normally you don't need to write the description, but yeah, these figure very important for on position and off position of the different things. Overall it's the same, but it's only the changes over here which is going to make this on or off. So very easy diagram for the staircase wiring. We now see the earthing part, but in the next video.